So first agenda item this year, right? We need to have something that'll bring some of our skills back, something that'll bring some of our concept knowledge back. So we're going to look at circles. Last time you saw them was probably the beginning of geometry, but they're good for us in terms of some of the manipulation that we work with when we solve. They're good for us in terms of understanding our transformations. So here we go, defining them, right? A circle is all that entire set of points that's a given distance from a given point. That particular point, right, we always call our center, and that distance is our radius. Now, if you remember from geometry, the circle was generated based on the idea of that distance formula, right? Because if we have a defined distance, there must be some way for us to calculate it. And the distance formula shouldn't be unfamiliar. It may be buried beneath some things we know, but it shouldn't be unfamiliar. Now, if we replace just a few pieces, we were told that we know about a distance for our circle. That was our radius, so we'll replace d with r. And then our center is the point we're measuring the distance from for every point on that circle. So a couple of pieces get changed. D sub for r. That x1, I'm going to replace it with h, the x coordinate of my center. That y1, I'm going to replace it with k, the y coordinate of my center. And now if I rewrite things just slightly, squaring both sides because the radical is a little bit of a nuisance sometimes, r squared is x minus h squared plus y minus k squared. That is what's considered the standard form of our circle. So in practice, how do we actually do anything with that? Well, we could be asked to define transformations, right? X plus 3 squared plus y minus 2 squared equals 64. Well, looking at that, I know that it's a circle that's been moved left 3. It's been moved up or down. That's the question. This doesn't look like we usually do. It's been moved up 2, right? Because it is attached directly to y as opposed to being on the other side of the equation or outside of that actual calculation. So we go left 3, we go up 2. And then instead of my radius being 1, my radius is actually 8. So now I've got a circle with a center at negative 3, 2, and a radius of 8. What if I'm just given details? Well, we take that generic form for standard form, and we plug in what we know. So we start with that standard form equation. We identify what our center is, we identify what our radius is, and we put the pieces together. All said and done, if we want to write an equation of a circle with a center at 1, negative 6, and the radius of square root of 5, yes, your radius could be anything, we get x minus 1 squared plus y plus 6 squared equals 5. Well, with every other equation we've ever looked at, there were always other forms that we needed to be conscious of. So are there any other forms for circles? There are. There's what's called the general form. Now, the general form, even though we say this is the general form equation for a circle, general form doesn't always generate a circle. Sometimes it's just going to be a point. In the case of x squared plus y squared equals 0, it's got a radius of 0. It's just the point 0, 0. Sometimes you're not going to get any graph at all. Sometimes it just doesn't make sense to the ideas of what we're trying to put in the plane. X squared plus y squared plus 8 equals 0. Well, if I move that 8 to the other side so that it looks like that standard form equation, it's negative 8. You can't have a figure in the plane with a negative distance identified. Those are just a couple. There's plenty more options where those came from. But in very many of the cases that we'll look at, that is actually a circle. X squared plus y squared minus 2x plus 12y plus 32 equals 0. Mouthful, a lot of moving parts, but it is a circle, I promise. How do we know what the actual details about that circle are? So here we go. This is where the manipulations that we've learned are actually useful. So, for starters, we move some pieces around. We want to collect terms that have x, we want to collect terms that have y, and we want to get that constant that will ultimately become the r squared value when we're all done on the other side of the equation. So I'll group x squared minus 2x, I'll group y squared plus 12y, and I'll move negative 32 to the other side. And when I do that, I refer to it as ditching the constant. We ditch the constant just before we complete the square. Now we're going to have to do it twice. Once for x, so x squared minus 2x, half of negative 2 is negative 1, squared is positive 1, I'll add that to the left side. Y squared plus 12y, half of 12 is 6, I'll square that, I'll add it to the left side. Now to maintain balance, I also need to add them on the right. I've now completed the square both for x and for y. I'll factor those trinomials that I created, one in the x variable, one in the y variable, and that leaves me with my standard form equation of a circle. That is, in fact, a circle with a center at 1, negative 6, and a radius of the square root of 5.